Hello, grade 12s. Here is another one, the probabilities. Another section that gives a lot of, chest pains or something. So let's see if we are getting an angina pectoris or we are getting a heart attack. So question 10 is probability. It starts off nicely with grade 11 stuff, or even grade 10 for that matter. A and B are independent events. So you can see once you hear the word independent events, you know the product rule is to be proven. In fact, is applicable and it is correct. Now the probability of A is a third and the probability of B is 3/4. Determine the probability of A and B. And we know if these events are independent, there is definitely an intersection. Okay. So we know that for 10.1, we know that P of A is a third and P of B is 3/4. Okay. Now let's answer 10.1.1. So we know that P of A and B is going to be P of A times P of B, since the events are independent. So this is a third multiplied by 3/4. So you just simply use your calculator there. 1/3 times 4/3. 3/3. When some boys soon buy these, 3/4, man. Damn it, man. So 1/3 multiplied by 3/4 or 3/4. That is the word I wanted to use, man. There you go. Easy stuff, guys. I'm gonna cry nice. Bengekho kwa chest pain, like no angina, nothing. I'm sorry to use that one. So better. So those are the 2 marks, guys. Substitution and answer. Straightforward. Straight and 2 BS, but don't drink, Nina. You don't need that thing. Alcohol is not good. Now I told you, find the probability of at least 1. So once you hear that word, at least 1, now at least 1 event occurs. This means it's either the event A or B. And we know here the addition rule applies again for independent events. So we've got, it's going to be P of A plus P of B minus the intersection, which is minus P of A and B. So this is going to be 1/3 plus 3/4 minus 1/4. Let's see. What is that? 1/3 plus 3/4 minus 1/4. So I'm getting a 5/6. So let's leave it as a fraction, 5/6, since we were given these things as fractions. So there we go, guys. There we go. Easy marks. So here you could even use Venn diagrams if you like. Oh, that one won't work, Kanin. But the problem is if I try to write on that, I start to have problems. It becomes smaller and it's not easy to read. So you can do Venn diagrams, do the intersection, and then you do the so-called the probability of A, probability of B as a whole, or you can say PA only, PB only, and the intersection. So you would still come to the same answer. So these ones, you can use a lot of your tools to assist you. So guys, again, this one is simply as substitutions and answer. No big deal. So let's do 10.2. 10.2 says the probability that it will snow on the dry on the Drakensberg Mountains in June is 5%. Okay. Now this simply means in June, as in any June. It seems like that to me. And now we're in 2023, So I don't know. They're not quite specific though in which June here, because once they start specifying a particular month, it gets me worried because I know the question is going to be a little bit silly. So what do you mean by June? Which June? Because they should tell us June which year. At least we would understand if we have to do probabilities. Okay, so I'm a bit worried about that statement. It says now when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below zero is 72%. Okay, if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below zero is essentially 35%. Now, all of this I cannot highlight, unfortunately, guys. So represent the given information on a tree diagram. Clearly indicate the probabilities associated with each branch. Okay, all right. Okay, so this is easy. So 10.2.1. And this is something I just revised with my students. And I know they killed this thing. When they saw it, they were like, we are taking you down. And you know what? We may even take you further down if we have to. But the issue was, this question was put down by my students because they were more than ready for this. We did a lot of these kinds of questions. Anyway, let's do the tree diagram. Obviously, we've got two events here happening. One, it's either it snows in this particular month or it doesn't snow. Okay, so we're going to say S for snow and S prime for when it doesn't snow. Okay, great, because that's what we know. If something happens, now when you get questions like this, when they're saying something happens, just think of its complement. If you were to think of it as an English word, if I say cry, then it will be did not cry or doesn't cry or not crying, So the complement of that is going to be that. So we are told here that the probability of snowing is 5%. So remember, probability can be expressed as a percentage, so that is that 5%. So this means this one is going to be 95% chance that it doesn't snow. So the snowing is just, a little bit, but more or less you will not have the snow. That's what this means. First, I'm done. But again, we are told about some temperature drop. Now we know that, well, if it did snow, the temperatures may drop, they may not drop. Okay, but that doesn't make sense. Okay, maybe let's say below zero. Okay, it depends. Yeah, it would really depend. So now we can talk about the drop as a D and it did not drop below zero as a D prime. Now we are told here that if it snows or when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. So this means we've got 72% here. Now the complement of 72 will be 60. What? Is it 60 or is it 28? I think it should be 28. Let's see, 100 minus 72, that is 28. So that would be 28% chance, because remember these two are complements and they are independent of that one. Okay, maybe they are dependent, we don't care, but these two should add up to 1. Those two should add up to 1. So that's how you deal with this tree diagram business. Wabona wankwa unkweshishile wantwisisa nakudzela ntiyiso. I wish I knew this languages so well, but for words, you know. So again, when it didn't snow, the temperatures could still drop. They do sometimes drop, even when there's no snow. Frost, not frost. Is it frost? Yeah, it's called frost. Okay, bene qabak. ubona uba nyhani xa kuzawuayisa ke ngoku singaphaya ko-0 bafowethu. So khe kube neqabaka nje lingakhithikanga. But the two are very difficult to separate anyway. So now what do we know? We are told here, if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 35%. So for the drop, it's going to be 35%. Now what is the complement of this one? It's going to be what? Is it 65%? I think so, 65%. Ek denk so. 65. So 100 minus 35 is 65. So we've done our tree diagram, guys, and then we're told to show clearly the probabilities associated with each branch. So nobody forced us to do the outcomes and all the shenanigans. We leave it at that. So we're scoring marks, Baba. We're scoring marks. So obviously we have a mark for that and a mark for this. Ne? Superb. The mark is for this and that and that. So that's how those 3 marks are scored. So the first 2 arms, and then for each one of the doubles, those are the marks. It looks like it, but I'm not too sure. You will have to consult the guidelines for the real thing, because you know what? Things happen, Baba. Things happen. So let's soon papen. So this is now 10. Sendiyayinyanzela bafowethu, but ingabhali kanje. You must leave spaces. Follow the instructions. If you don't leave spaces between sub questions, you are going to be taken down even when you've done everything correct. So 100% is not just calculating the mathematical questions. It's also adhering to the instructions, leaving spaces, making it legible, because you lose marks even not on maths, guys. So be careful. It's not about the maths alone here. It's a comprehensive thing. Okay, let's not talk too much, guys. We're not interested in losing time. So calculate the probability that the temperature in central South Africa will not drop below 0 degrees Celsius in June 2024. Now I have a problem, because there's suckers right here. They're talking about June 2024, but here we just spoke about June. So now June, it means any June, okay? That's what I can interpret, because it didn't say in June 2023. And then now we're using this data to project into 2024, but this just says in June standard. So when they say June 2024, that one is unnecessary, but it's just trying to say, okay, we can use these predictions even for the next year, okay? But that June 2024 should not scare you, unless they had something to say here. Okay, so now the probability that calculate the probability that the temperature in central South Africa will not drop. So the will not drop part is that it snows and it doesn't drop, okay? And then it doesn't snow and it doesn't drop. So it's either that complete arm or this complete arm, or you can say branch, whatever. So the probability of event, I just use event, it's either going to be the probability of S and D prime, or the probability of S prime and D prime. That is the event right there. So this is going to be essentially 95% times, you're lying, so Palin doesn't get a command. Substitute correctly, S and D. So this is 5% times 28% into, either or is a plus. So that is 95% times 65%. Okay, you can just punch it in the calculator and get the answer. So we've got 5% times 28% plus 95% times 65%. Okay, so I'm getting this one as a decimal, so I'm still interested in showing it as a percentage. So I'm getting a 6,315, okay, which is going to be essentially times 100. This one gives us a 63.15%. Okay, great. So that is the answer. So they gave me in percentages, so always try to be relevant to the question. If the question, the given statements are in percentage, try to use percentage for your answer, because but again, it's probability. You can still leave it as a decimal. I doubt someone is going to take you down for it. So that is the story, guys. So easy 3 marks essentially, because now this calculation is a calculation on its own, and that calculation is a calculation on its own, and the answer. So that's how we score those 3 marks. So there's no need to think of substitution. But I'm sorry for the coughing. Sorry, guys. Hey, yeah, I'm not so 100%, and it's been happening for a while now. My lungs are the naughty ones. They recover after a while. All right. Okay. All right. So the other way, I would give 4 marks here, because trust me, to know how to set up this equation as a result of saying we're substituting into a correct equation, I would give an extra mark here. This is essentially a good 4-mark question, essentially. But yeah, I see you with 10.3. 10.3 says 10 learners. Can you see there's 10 of them? So we've got 10 learners here. Now are randomly standing in a line, one behind the other. Okay, all right, okay. Now it says, in how many different ways can the 10 learners stand in a line? Now 10.3.1. We know that we've got 10 spots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let's say this is the front, that is the back. For the front, we have how many options? 10 options, but we're placing 1 learner. 9 options, we're placing 1 learner. 8 options, 1 learner. 7 options, 1 learner. 6 options, 1 learner. 5 options, 4, 3, 2, 1. Okay, so we simply multiply all of these out. So this is just multiplication. So this becomes a 10 factorial. Because they are standing in a row, it means we're not repeating. Basically, this part that says in a row, it means we can't repeat. Because can you repeat an individual? You can't. It's either they are there or they are not there, right? So this is the story there, guys. This is the story. So I'm getting a big number there, 8800. How many numbers? 1, 2, 3, 4, 5, 6, 7. So this is 3,628,038. Yes, that's the one. So we can say different ways. Different ways. So if you want to read that in total, that is 3 gorillas, 628 squatters, 38. Hey, when uzawubethwa moni total practice. So anyway, let's go. What is the story now? We've got 10.3.2. It says now calculate the probability that there will be 5 learners between 2 youngest learners in the line. Okay, we still have 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now we've got restrictions. So I'm going to make this restriction be the position of the first youngest learner. So we're going to have 1, 2, 3, 4, 5 learners in between. That means this one is going to be the position of the second youngest learner. So now when we start with the restrictions, there's 2 youngest. So that means we've got 2 options for that spot. We've got 1 option for that because there are only 2. Now, what do we say? There must be 5 learners between them. So this as a whole is a restriction. So this is a unit. It means these ones must be together like this. Okay, all right, okay. So now there's 2 ways of thinking about this. Let's just first do the first way. We know now, for these other spots, we just put the others randomly. So we had 10 learners, we took 2 down. So there's 8, 7, 6, 5, 4, 3, 2, 1. So this is my usual technique. So this means this unit here can be here, right? It can be where it is, or it can be here in between these 2, it can be there in between these 2, it can be on the other side of the 2. So we don't care where it is, but it can be there. So this means we will have here, essentially, this is 2 times 1. This is basically 2 factorial times this is 8 factorial if you look at it, because it's from 8 going down to 1. So this is 8 factorial. But how many times can this happen? 1, 2, 3, 4. So times 4. So we've got 2 factorial times 8 factorial times 4. So I'm getting 3, 2, 2, 5, 6, 0. Now, this is different ways in which we can place these guys in this manner. Now we can say, therefore, the probability of the event occurring is going to be the number of ways in which this occurs over the sample space. The number of ways is 3, 2, 2, 5, 6, 0 over. Now this is going to be over 10 factorial because they were 10 factorial in total. But then this part of a constraint is just a portion of that 10 factorial. So just divide that by 10 factorial. So we get 4 over 45. Okay, that looks all right because it's less than 1. If you get an answer greater than 1, then you know, ooh, you are dead. You didn't do it well. You didn't do it well. All right, guys. So that is fine. That is fine. So what do we do now? We get the marks. That's what we do. 4 marks. Where does it come from? There's 4 marks. Be substitution, be answer. I'ma cry nice. This question was easy. I mean, this probability was so easy, guys. No one had to crack their skull, so they knew that this thing is a headache. So let's just give these guys I'ma cry nice. Actually, so you guys have got I'ma cry nice. I hope you enjoyed this one. So let me show you the other technique, which is not so different anyway. Just to do that part. So we've got how many spots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, we just start with the restrictions. So always do the restrictions first. 1, 2, 3, 4, 5. Then the 6th spot is the second spot for the youngest. So this is 2, then 1. And then we are told this must be a unit. Okay. So the other way to look at it is to say, okay, how many options do I have here? It's 8, 7, 6, 5, and 4. But then this whole unit can be here where it is. It can be on the next position. It can be on the next position. It could be on the next position as well. And essentially, what does this mean then? This essentially means this is going to be 2 factorial times 7 times 8. Okay. This is 7 times 8 times 2 factorial times 8 times 7 times 6 times 4 times. Now you can say 1, 2, 3, 4. So this is going to be 4 factorial. You should be getting the same answer, 3, 2, 2, 5, 6, 0. And then you proceed as above. Okay guys, I hope you enjoyed the video, and I will see you when I see you. Bye bye.